Have you ever pondered the true power of the sun, the star at the center of our solar system, that we see every day? This isn't merely a glowing orb in the sky. It's the very life force that sustains us. It's our sun, a star that is so much more than just a celestial body. This radiant sphere is our primary source of energy, the powerhouse that drives our planet's weather patterns. It's the engine behind the winds that caress our faces, the rains that quench our thirst, and the seasons that shape our years. And it's not just the Earth that relies on the sun. The energy from the sun fuels photosynthesis, the process that plants use to convert light into food, creating the oxygen we breathe. It also affects our mood and health, with its light influencing our sleep patterns and vitamin D production. Yet, the sun is more than just a brilliant ball of burning gas. It's a complex celestial body with its own fascinating secrets. Did you know that the sun, much like an onion, has several layers, each with its own unique characteristics and functions? Let's dive right in, shall we? At the heart of our sun lies its core, a hotbed of activity where temperatures reach a staggering 15 million degrees Celsius. This is where nuclear fusion occurs, converting hydrogen into helium and releasing an astonishing amount of energy. Moving outwards, we encounter the radiative zone. Here, energy travels slowly, taking thousands of years to reach the next layer, the convective zone. This zone is a turbulent sea of swirling gas, carrying energy to the sun's surface. The sun's visible surface, or the photosphere, is where light finally escapes. Above this lies the chromosphere, a layer of reddish glow visible during solar eclipses. Finally, the sun's outermost layer, the corona, a fiery halo, extends millions of kilometers into space. Understanding the sun's structure brings us closer to unraveling the mysteries of this life-giving star. Despite its constant presence in our sky, the sun is anything but static. It has its own weather and temper tantrums, so to speak. It's a fiery ball of gas that's always on the move, constantly changing and evolving. And like a restless child, the sun has its moments of intense activity. Among the most fascinating displays of solar activity are sunspots, solar flares, and coronal mass ejections. These are not just random occurrences, but are part of a larger cycle that the sun follows, known as the solar cycle. This cycle lasts for about 11 years, during which the sun's magnetic field flips, causing a surge in solar activity. Now let's dive a little deeper. Sunspots are darker, cooler areas on the sun's surface caused by intense magnetic activity. They're the starting points for solar flares, which are sudden, dramatic increases in brightness. These flares can release as much energy as 1 billion atomic bombs. But wait, there's more. Coronal mass ejections are even more powerful. They're huge bursts of gas and magnetic fields that are shot out from the sun's corona, or outermost layer. When these interact with Earth's magnetic field, they can cause beautiful auroras. But they can also disrupt technology, causing blackouts and interfering with satellite communications. The sun's temperament, while occasionally disruptive, is a testament to its dynamic nature. As humans, we have a limited lifespan. But what about the sun? Our sun, like every other star in the universe, has a life cycle. It was born from a nebula around 4.5 billion years ago, gradually accumulating mass and pressure until nuclear fusion ignited its heart, giving it the warmth and light we rely on today. For now, the sun is in its prime, a stage known as the main sequence. It's been burning hydrogen into helium for billions of years, and it has about 5 billion more years to go before it exhausts its hydrogen reserves. When that happens, the sun will evolve. It will swell into a red giant, engulfing the inner planets, possibly even Earth. The sun's evolution won't stop there, though. It will shed its outer layers, leaving behind a dense core known as a white dwarf. Over billions of years, this white dwarf will cool and darken, eventually becoming a black dwarf, a dead star. What does this mean for us, for life on Earth? If humanity or our descendants are still around, they'll need to have found a new home. As for the solar system, it will look drastically different, with the sun's planets either consumed or flung into the depths of space. The sun's future is inevitably tied to ours, making its study crucial for understanding our place in the cosmos.